Absolutely. Absolutely not. Oh, because they didn't do all. Yeah, they got kind of mixed up because we added on. So just, yeah, just count how many they did. All right, so this is what we started with where it said they, or I guess not they, Sylvia had a pool that needed to be emptied, cleaned, and then refilled. We had the different stages. And then you guys came up with a graph on your own, and we had a story. That's, that's dumb, right? Yeah. Yeah, we're just going through the notes. I'm going to just tell you guys what stuff from the notes is going to be on the test. Okay? So, not this. All right? You're welcome, but you can just call me Mr. Aldrich, is fine. All right. Let's take a look. You guys have the problems too, right? Let's take a look at these. So then we did some problems. Graph each of the functions, name 3 points that lie on each graph. Yeah, so this is from the homework from lesson 1. So that seems like, yes, you should be able to do that for shizzle. How about if I throw a linear one at you and a exponential one at you? Like one of these won't be the exact same, no, and one of these, but that general idea, okay? So do you want to like just review real quick how to do each one of those? Okay. All right. So we have to, it says choose a scale for your graph that'll make it possible. Um, you know the key here is that this is going to cross the y-axis at 5, right? So I'm going to draw my scale so I know for sure I can get, I can get y equals 5 on there. Okay. That is the starting point. 1, 2, 3, 4, 5. That's the y-intercept, yep. And then, yeah, and then the slope is -2, so you go down 2 over 1, down 2 over 1. There's my 3 points. 0, 5, 1, 3, and 2, 1. And then if you connecto el datos, then you get el grafo. That look like that Okay. We have to name 3 points. They don't have to necessarily be those particular points, but those are the ones that seem easiest to me. Yeah, the y-intercept and then a couple after that, right? So you guys have any questions about how that just happened? You feel okay about that? That's easy. Yeah, I mean, not that exact function. You can turn it in tomorrow with your test. Okay. You don't have to. That's why it's extra credit. Okay, then for a for a yeah, so I'll give you those slips tomorrow too, so you can tell me. So many questions, young grasshopper. Yes. So when you guys walk in on Monday, you'll all have A's. Even you. Okay, so this one is an exponential one. Hopefully you guys recognize the different form than the first one. The variable is the exponent and they're being multiplied together, not added or subtracted. This is our starting point and then it triples each time. So if I'm going to get in 3 points, I don't think I can go by ones. I'm going to have to go by 5s, yeah. The 5 is not the slope. Yeah, the 5 is the y-axis, the y-intercept. So the 5 is where I start on the y-axis. This one doesn't have a slope because it's curved. But what you do know is since this is a 3 right here, that means it triples. So when I started at 5, 5 times 3 is 15. So my next point is going to be at 15. And then 15 times 3 is 45. Yep, it's crooked. So then my 3 points, I can go with the first one, which is 0, 5 again. I wonder if that's a coincidence. And then 1, 15, and then 2, 45. So this 3 right here means that when these numbers go up by 1, these numbers triple. Apology not accepted. And then the 3 is what you multiply by. Yep. Yep. Okay.
Like I get the points, but I don't know how.
Let's see if there's another one that maybe. Okay. Let's try number 4, because that's the same sort of type of thing. So when you see 4 times 2 to the x, here's what I would love for you to think. 4 equals your starting point, and 2 means that it doubles. Okay? First number is your starting point, and the number after that is,
So then it'd be 8 times 2.
yeah, yep, so it'd be 4, and then 8, and then 16, and then 32, and then 64, and then 128, and then 256, and then 512, and then 1024, and then 2048, and then
So what is
the x just goes by normal, just goes by up by 1 each time. Oh, the x tells you, the fact that it's in an exponent tells you that it's going to be a multiplying one, a curved one, not a straight one. Okay. Okay, so we started at 4, and then when you scoot over 1, you go up to 8, and then if you scoot over 1, you go up to 16, and then if you scoot over 1, you go to 32. So 0, 4, 1, 8, 2, 16, 3, 32, those are all good options for points. Trying to see what's going on in there and they get too close. I don't know what to tell you, Abby. It's so crazy, it just might work. I'm sorry, what? Yeah. Yeah, they already do that. There's tunnels like that up into Canada too. They find them every once in a while that they use to. Oh, across the lake, maybe. But yeah, they for smuggling drugs, they build tunnels under the thingy. Okay, so you guys are good with those? What? Number 5? Sure. Where does that start? Okay, yeah, that's a little tricky. Do you want to change the scale or do you just want to go for it? We can just go for it. We can just go for it. So it starts right there. What? Yeah. Oh, the graphing part? Yes, I agree with you. I feel like the whole graphing thing is overemphasized and a little bit outdated. Like, you know how to make a graph. Okay, so this starts at -4, and then the slope is 2.5. So that I'm going to go up 1, 2.5, and then over 1. And then the next one I'm going to go up 1, 2.5, and then over 1, and then up 1, 2.5, and over. Jaron? Yeah, which is a little bit weird. Yes, no, you're right. It's hard to keep that in mind that when it's linear, you start at the second number, but when it's exponential, you start at the first one. Right. And I have seen some math books that do this by going -4 plus 2.5x to deal with that confusion. But you've been ingrained so much for your whole lives, this whole mx plus b thing, that this causes more confusion sometimes than, but yeah, you're right. Okay. This was a fun little matching graph problem, but I don't think we'll do anything like that. Definitely not going to do any similarities or differences. We can throw some easy equation solvings on there, though. Yeah, the last test had a bunch of those. That was really nice. So how about one of those and one of those? So one that's exponential and one that's Nathan?
That's why they land on the power line.
Yeah, so I just told Alexa. Yeah, I just told Alexa. Talia? Number 20. So you want to do 19 and 20? Okay, shh. Whoa, Lindsay. Get Lindsay. Nathan? Nathan? You got a test tomorrow. Right.
I need to see better. It's going to make my eyes better.
Okay. Oh, I thought you said 19. Yeah, 19 is a doable one for the test, yeah. And so is 18. So I think I'll throw one and 20. Okay, 20, just a little bit. Yeah, you just have to start by adding the 22 first. Yeah. Okay. All right, so we good on that one? Okay. Uh-huh. Oh, okay, sorry. Nathan? Weston? Graphing, we're going to go one, just plain linear one exponential one, and then why not throw one at you where you have two linear ones at the same time, where you have to find, Matthew's gone today, where you have to find where they cross, okay? So this isn't any different than the one that we did before. We did this a second ago. You just have to graph two lines instead of just one. You could, yes. Yes, you could. All right, so you girls are working on the work back there, I'm sure. Are you ready for the test tomorrow? Great. What? What? Tomorrow? So I gotta bring a sandwich, is that what you're telling me? Yeah. So they don't have to go down to the teacher's lounge and microwave it and bring a sandwich so I can eat in my room. I don't usually eat in my room. Okay, so 2x minus 7, 1, 2, 3, 4, 5, 6, 7. So this is what will forever be known as Jaron's rule, that for a linear one, you start at the second number. So we started at -7, and then we're going to go up by 2. So up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. And then if I connect those dots, that gives me, that gives me the line. Then for the second one, where do I start? At +5. 1, 2, 3, 4, 5. Okay, 1, 2, 3, 4, 1. 1, 2, 3, 4, 1. Aha! 1, 2, 3, 4, 1. Okay. Wow, that was in unison. That was pretty cute. 2, -3. What? Test tomorrow. Yeah. Extra credit puzzles. Yeah, Kahoot or something like that. Nothing. Nothing major. And then we start the. Well, so far we've got 1, 2, 3, 4, 5. We're up to 5, but we're only on lesson 2 out of 7. So what? Yeah, one of these. Okay. Now McKenna points out. She makes a very good observation. That one of the things we talked about later in this unit was that you could solve these by just setting the two equations equal to each other, not graphing them. So she says, why don't we just go 2x minus 7 equals -4x plus 5? My response to that, why not do both? And then you'll know for sure that you're right. Because if the graph matches the algebra, then you know. Okay? So set them, if I set these equal to each other, and I add 4x to both sides. So then I have 6x minus 7 equals 5. And then if I add 7 to both sides, then I get 6x equals 12. So that means x equals 2, which is what we got for the intersection point. Uh-huh. Well, yeah, I think that's the main, like, I think that Dylan is wrong, but you're almost right. What I would agree with is that you're never going to graph anything by hand. You might end up graphing things on a computer. Right, and that's what I would like for you guys to be able to do it on the computer, and then be able to, answer questions about the graph. But making the graphs itself, nobody does that. Right. So I would like to, instead of spending so much time doing this stuff, I would like to spend more time, do this on the computer, then like figure out what you actually do with the answer, like have it mean something instead of just, Right, yes. Yeah, exactly. Okay, so these are all just straight lines. Okay, so no worries there. All right, so what about this? Increasing, decreasing. Seems like this came up a lot, didn't it? Yeah, this is.
It's kind of confusing. It's not confusing. It's just a lot of writing things down.
I'm gonna put that on the back burner. Okay, I'm gonna give that last one a question mark. Are we up to 5 problems so far? I should probably keep track. So we had a linear graph. We had an exponential graph. We had system of linear equations, and then we had one linear equation so far we decided to solve, and then we also had exponential equation. Okay, so those are our 5 questions so far. Okay, let's toss on top of that, coming up with an equation for both a linear and an exponential from a table. Okay? You do know the recursive and not the explicit? Okay. So maybe I could let you choose one or the other? Maybe. Okay, you're all right with that? All right, so the explicit equation for this is that these are going down by 3 each time. Okay, so it'll be y equals -3x. And then what would be the one up here at 0? Would be 8. Did you just say 8? So you do know how to do this. Right, okay. So then the recursive one, you would say, I haven't been making you guys do the starting point in recursive, but technically you need to say what's the first point. So the first point is 5, and then to get the next one, you take the one before it and subtract 3. Like that. No, because we haven't been emphasizing that. Yeah, right. No, I won't throw anything like that at you. Dylan? Uh-huh. So the recursive... Okay. Right. You write down the stupid stuff with the -3, yeah. And I don't think this is actually, I think I did that wrong. I think that's just supposed to be f of n. You get the 1, but yeah. Is that right? Okay. All right. So then for this one, what's happening each time? Now it's doubling. Yeah. So this is going to be a exponential one. What is our starting number? What is it at 0? 3. So we're starting at 3, and then we're doubling each time. Okay? Yeah. So then the recursive of this would be, my first number is 6, and then to get the numbers after that, I take the one before it and multiply it by 2. Yeah. Literally. Yeah. I guess in the other ones they put it in parentheses, so maybe that's less confusing. So let me rewrite that. Right, so let's do it like that. Because if I go back to where x equals 0, y, that's what y equals. So that's basically where it crosses the y-axis. Because this is going times 2, and then times 2, it's doubling each time. It's not going up by the same amount. It's doubling, okay? Nathaniel? Jaron? You have to what? No, and I think what McKenna and I disagreed on is that you only either need to be able to do the explicit one or the recursive one, but not both. So the problem will be phrased, write a formula for the, write equations for the table, and then you can just pick. Okay? Now I'll be able to figure it out. Uh-huh. Guys learning real well over there? Watching yesterday's stuff? You're all caught up? Okay. Yeah, so, because you were like, it is +4, but it's got a missing piece in there. And I told Talia we won't mess around with that kind of stuff.
So what if you use F1?
That's just, I haven't been doing that with you guys, but if you're going to do the recursive, you do technically have to give a starting point. It doesn't actually have to be F1. You could say F2 equals 12 or F3 equals 24, but you need to have one point that you know. This just says like multiply it by 2, so the question would be multiply what by 2? I have to give you, that, whatever. Dylan, you good? Okay. All right, so now we've added, now we've added two things onto here. So, yeah, just a sec. So recursive or explicit linear. And then also, no, just candy, yeah, and it's old man candy, so explicit, I was at, said y, and this one you start at the second number, and then this one you start at the first number. And I don't have a good answer for that, except for that is how someone decided to do it, and yeah, when you're doing the exponential ones, when you're doing the multiplying one, the starting numbers first, and then this is what you multiply by, which makes sense, right? Because the first number is where you start. So this should be the easy one. This is the confusing one. You don't start at -3 and then go up by 8. You start at 8 and go down by 3. So that's just something maybe you could make a note of on that piece of paper so you remember which one is the starting point and which one is the direction. Okay, so that's enough for lesson 2. With that one, we got only 5 more to go. All right, so you guys are really resisting this whole situation here. If looks could kill, McKenna, then there'd be a memorial for me this weekend. Yeah, don't really like that very much. Yeah. Okay. I do have some to pass back to you, yeah. Okay, and then we didn't really want to do that, and we don't really want to do that. All right, so let's go to the problems again and see if there's some good stuff in there. Oh, yeah, definitely. So now we're given the function, and we have to fill in the table. Okay? And I love that circle the point of intersection situation there. That's a fun, yeah. So do you want me to go through this one? Okay, so for this one, the way that I fill in this table here is I just plug in these numbers for x. I would do what? Oh, for g, yeah, I would do 0 plus 1 is 1, 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 1 is 4, and then 5. Okay? And remember, I don't know if this is asking too much, but this number, once you get going, the number in front of the x tells you the pattern. So this one, they're going to go up by 1. This one, they're going to go up by 3. If I put a 0 in there for x, 3 times what? 3 times 0 is 0. 0 minus 5 is -5. And then 3 times 1 is 3, minus 5 is -2. And then 1, and then 4, and then 5. Okay? Sharon? Uh-huh. All right, and then where they would intersect would be where the two numbers are the same. Huh? Yeah, exactly. So we've done the intersection basically algebraically on a table and then also on a graph. So now we're up to 8. Okay, hold on a sec. So fill in a table. Yep, hold on a sec. You're freaking out that you won't write it down in time? Big bike ride today, Abby. Yep. 3 times to Lake Sylvia. Did that once before. Let's do it again. 3 times to Lake Sylvia, then around the little loop, and then Lake Sylvia, and around the little loop, and then it's Lake Sylvia. 3 times. You know that all the old people like me walk where you like come down 3rd Street and then you turn left and you go down the street past the tennis courts and then you go that way and then turn left on I don't even know what up to the old folks home and then down McBride. That's like that's a people walk that loop all the time. Yeah, right. There need to be sidewalks on McBride.
I bring my bike from like Wainuchi all the way to Brookville.
Nice. Some true false questions, huh? Do you? Huh? You don't like these? Yeah. So when you retake that state test for the last time this spring, we we need to talk about that. 'Cause I know that's why you're not doing well on that test, because you're overthinking it. You need to just go for it. I don't know if you have to retake it one last. You retook it in the fall, yeah. But I know, but what if you don't pass this class? Wouldn't you like to have that?
Well, even if you didn't pass this class, then you would get credit.
Right, that's true. Okay, how about lesson 4?
Yeah, but you take the test, that's still not credit.
Okay, I'm going to give you this one, yeah.
State test is credit.
Okay, I'm going to give you guys, Nathan, I'm going to give you guys Allie and Dane drain the pool. Because I think this is a good problem, because it makes you think about like a real world situation and connect it to some math, okay? So that's going to be, yeah, this is the water park one. So this, I'm going to give you some questions about Allie and Dane. Drain the pool. Okay? It's not going to be the same ones that are on there. I mean, okay, I'm lying to you. It is going to be the same ones that are on there, except the numbers are going to be different. Okay? You got it. You got it. The true and false ones got voted down. No, you can't put trolls, but you can do this. And then when you get that marked wrong, then you go, no, that's supposed to be a true. And then if the answer is false, you go, oh no, that's that I wrote down F. That's it. I just got carried away on the. Yeah, I just was nervous because it was a test. That's supposed to be a T. No, that's supposed to be an F. You can go either way. All right, so then for the nope. Nope. We already did that, right? Okay, so nothing new there. All right, we're cruising now. Okay, Allie and Dane. I'm not going to go combo Allie and Dane on you. So, yep, we don't need to do that again. What about the homework? Yes. Okay, so pay attention to this, Nathan. This is a tricky one. So, I'm going to give you a function. And you have to plug values into the function. You also have to say what value will make the function equal that. Okay? So h of negative 4 is negative 13 because 2 times negative 4 is negative 8, minus 5 is negative 13. Okay? H of 1 is what? And just put it into this function right here. You put it in first. Negative 3, good. 2 times 1 is 2, minus 5 is negative 3. Okay? H of 10 is what? $15. Okay? You guys understand? Just plugging that in for T. Yep. Okay? Yes, and so that's these over here. So this one says if h of t equals 23, so now I'm going to say 23 equals 2t minus 5. So then you add 5. So 28 equals 2t, so t equals 14. Okay? How about if I told you that h of t equals 31? Then you go 31 equals 2t minus 5. Add 5. So there t would equal 18. Okay? So two different ones. One, you give a function, you plug in a value. The other one is figure out when it equals that. All right? All right. Yeah. So same thing from this. Okay? Not here. I know this is something that we struggled with a little bit, but this is also important. Okay? So g of 2 means plug x equals 2 into this graph. So here's 2, and then you go up to the graph, and I think it's actually 9. You just can't see from back there. Okay. We did fight over, no, I thought it was 10. You guys said it was 9, and you guys are definitely right. Yeah, okay. So this one would be 9, okay? Then this is asking the same thing but opposite. This is saying when the graph equals 3, what does x equal? Yep, good. So now you go to 3 here, and then you go this way, and the answer is 1. Okay? So you guys should be able to look at a graph and figure out what y value goes with the x value and also what x value goes with the y value. Okay? Yes. But no, it's going to be the y-intercept. It's going to be where it crosses the y-axis. Hold on a second. Hold on a second. Okay. Because remember, g of x is just a way of saying y. Okay? So if g of x equals 3, that's saying y equals 3, what is x? Okay? So I'm going to go up to 3 on the y-axis and then go over to the graph and then down to the x-axis. So that gets me 1. This one is saying if x equals 2, what is y? So you go to 2 on the x-axis. Yeah. What's that? Is B, C like A? Yeah, same thing on there twice. Yeah. Okay, so try this one, Nathaniel and Dylan and Weston. Try this. What is R of negative 1? In other words, when x equals... Hey, Lindsay. Lindsay. When x equals negative 1, what is y? That's what it's saying. Correct. Okay, so you go over to x equals, this is the x, this is the y. So you go over to x equals negative 1, you go up to the graph, and it's 10. Okay, then this one, remember, is backwards. This says when y equals 4, yep, you go over to the graph, and x equals 1. Okay, and then this is saying when x equals 2, then y equals 1. Yeah. Uh, We on 6 now? That was 5, I think, yeah. Okay, so this first one looks like the same kind of question. So we already have addressed that. You guys probably don't really want to do the adding them together or the greater than or less than. No?
I mean,
We're good.
that looks complicated. It's just one problem, and we all know.
Okay, so then we did it with the function, we did it with the graph, and then now we can do it with a table. So what is g of negative 3? So when x equals negative 3, what does the g function equal? Negative 5. Because you go down to negative 3 and you go over to negative 5. Okay? All right, for what values is f of x equal to 0? Well, it's 0 right here and right here. So that looks like x equals 1 and x equals 2. Okay? No, 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 no. Okay? So just the... Okay, and then this is the last thing that I'll throw at you guys. This is what McKenna did at the very beginning. No, you're being as loud as they are. So if I'm going to kick anybody out, I'm going to start with you. Really? I'm aware. Okay, this is what McKenna was talking about before, which is the other way that you can find the point of intersection is to just set the equations equal to each other and then solve for x. So we'll throw that situation on there too. Okay? That's just what we did before. Same thing. Okay. All right. So that would be the last one, lucky 13. Nah. Well, this one has an A and a B. They both have an A and a B, so it'd really be 13, 14, 15, like 16. This one might have more, it's not going to exactly